In this lesson, we will look at these fuel controls. Select each of the fuel controls in turn to find out where it is located, or the forward arrow to continue. The highlighted areas indicate where the fuel controls are located. Let's look at them in more detail. The fuel control panel has three distinct parts. Those push buttons, which control the overall flow of fuel to the engines and APU, those associated with the automatic feed logic, and those controls which affect the CG control. We'll look at them separately, starting with these controls. The engine and APU low-pressure valve annunciators indicate the position of the low-pressure valve. Here the valve is open. A fire has been detected in engine 2. For training purposes, the fuel page has been called, so you can see the effect on the low-pressure valves. Select the control to switch off fuel to the affected engine. The low-pressure valves cannot be manually operated, and they close only when the respective fire handle is pulled. The next push button controls the operation of the fuel crossfeed valve. Here the valve is closed. As you can see, we had a problem with the left inner tank pumps, and they have been switched off. Press the push button to allow engine 1 to be fed from the right-hand side. Notice the message Fuel Crossfeed appears as a reminder on the memo page. Let's continue with this problem. These four guarded push buttons control the position of the isolation valve for their related fuel tank. Here the valves are open. To cure the fuel imbalance and gravity feed from the left inner tank, we need to close the crossfeed valve and shut off the left outer isolation valve. The crossfeed valve has been closed for you. Lift the guard to select the control which will shut off the fuel supply from the relevant outer tank. Engine 1 will now gravity feed from the left inner tank, rather than the left outer tank. A final point to note regarding the isolation valves. The isolation valve push buttons in the centre of the panel shut off the fuel supply from the centre tank pump as well as the inner tank on their respective side. These four push buttons control the pumps in the outer tanks. The outer tank pumps operate permanently at a lower pressure than the inner or centre tank pumps. They are used as a backup feed for the engines when the other tanks are empty. The outer tank pumps are not involved in the automatic feed logic, which we'll look at next. These three pairs of push buttons permit the selection of the automatic feed mode logic. Here all pumps are in the normal position with all the lights out. In this case, with one pump in each tank selected normal, the automatic feed mode still works. However, you should cross-feed the fuel using the other centre tank pump. The automatic mode is deselected only if both pumps in the centre tank or all four pumps in the inner tank are switched off. If this happens, the fuel flow to the engines must be manually controlled using the individual push buttons. Next, we'll look at the final push button, which is related to the engine and APU feed, the ACT. The ACT, or additional centre tank, provides, as the name suggests, additional fuel for the centre tank. One or two ACTs are options on this aircraft. In the normal position, auto, fuel transfer from the ACT to the centre tank is automatically controlled in flight. Manually transfer fuel from the ACT to the centre tank by selecting the appropriate push button. With the ACT in forward, approximately 1,000 kilograms of fuel will be unusable in ACT2. This fuel is usable again if the push button is released to the auto position, provided there is no fault. That completes our look at the controls for engine and APU fuel feed. Next we'll look at the CG controls. In the auto position, the CG is automatically controlled in flight by the CGCC, provided at least one trim tank pump is selected on and the trim tank isolation valve push button is in the auto position. Let's transfer fuel forward manually from the trim tank. In forward mode, any trim tank pump which is selected on will be activated to run. If both trim tank pumps fail or are selected off, fuel transfer will be by gravity. In the normal position, the trim tank pumps are activated according to the CGCC logic, provided at least one is on. With both of them off, CGCC control is disabled. No automatic transfer will occur, although CGCC monitoring and warnings are still available. Manual forward transfer is available. Finally, the trim tank isolation valve push button is used to shut off fuel to and from the trim tank. Here the valve is open. Lift the guard and shut off the trim tank isolation valve now. The valve is now closed. This valve is not shown on the ECAM, but all trim tank transfer is inhibited when it is closed. Next, we'll look at some non-ECAM indicators for the fuel system. As well as on the fuel page of the ECAM, the fuel quantity in each tank is displayed on the fuel quantity indicator on the overhead panel. The indicator has a separate display for the fuel mass in each of the 4 wing tanks. A fifth display shows the sum of the centre, ACT and trim tank quantities. A fuel flow, fuel used indicator, located on the bottom of the centre panel, is provided for each engine. The actual mass flow to the engine is indicated by a pointer in thousands of kilos per hour. On this digital readout, the total fuel quantity used or consumed by the engine is indicated in thousands of kilos. Before answering some questions, here's a chance to practice all the fuel controls you've seen in a free play situation.